On the
I
same
believe
boat?
so as well.
Okay. Okay. Hi, Desmond. How are you?
I'm all right. How are you?
I'm doing good.
Been a
Hanging in
while.
there. I am on Java version, I don't know.
All right.
Okay, so um, file handling in Java is no different. Other than that, the classes are different in Java. Java supports two different ways of doing file handling. One is called the Java I/O approach, which is the much older approach. And then we have Java NIO approach, N as in Nancy IO approach, which is non-blocking IO. Usually in Java environment, when we go higher up in more complicated stuff, Java does multi-threading, which you will learn about next semester. In networking, in multi-threaded applications with Java, multiple threads want to access a resource. So if the resource is blocking, what happens? For every little operation, it makes all the other threads wait till it is done. In a non-blocking IO operation, what happens is that all of the threads can still share the resource, provided nobody is updating the resource. So that's Java NIO package. So since you guys already know what is file handling, it's pretty much about writing a program that lets you communicate with a file to perform the day-to-day operations. That's pretty much the Java NIO stuff is. Let me share my screen here. Okay, you guys can see it. So you can pretty much be going to the same pages in the book as well, but I want to take you to the very first thing in the chapter on page 443, and that is the package called Java NIO.file. This is the package that Java developers created so that you can work with the files in Java. So NIO is newer package and IO is the older package. It used to be java.io package before, okay? Now, with the Java NIO package, we use different classes to do different jobs. For example, the file system class allows you to access the file system that you are working with. Similarly, there's another class called path, which uses the file system object. If you give it the path of the file, it tries to locate the file on that path and works with the file, pretty much. That's what basically the file path object would do of path class. It lets you talk to a file provided you give it the file path. Now, what exactly is a file system? All operating systems have their own file system. So file system is a way an operating system handles its files. So Java developers created a special class called file system, which actually grabs its file system from another class called file systems. That is a class that Java developers created to communicate with all possible file systems. It's like a factory class. That factory class then taps into your local file system and hands it over to the file system object. File system object can also call get path in a slightly different fashion. Can you guys see the difference between the two formats here? So here we use the two slashes. Why do we use the two slashes? Because one slash means escape sequence character. If you do not want to put two slashes, if you want to write a code that is not one operating system dependent, then you can ask the file system to get you the separator. Whatever separator is based on the operating system, it will automatically bring that. So that's why it's a better approach than using two slashes. Okay. Okay, moving on to the next page. These are the methods, some of the methods of the path class to help you return the string representative of the path, which is the whole path, or just the file name, or just the number of names in the path, including the folder names, or get a name at a particular location in the path. Okay. For example, have a look at this code. This is a file. How many names are here? 1, 2, and 3. There are 3 names: Java, chapter.11, and data. Java is 0, chapter.11 is 1, and data is 2. And that's exactly what the program does. Once it says file path.string, it displays the whole string. When it says the file name, it only displays the name of the file with extension. When it says there are how many elements, it says there are 3 elements. What are their index numbers? And then it goes index numbers 0 through 2. Every time you call the file path with a get name and provide an index, it returns one of the 3 names one by one: Java, chapter.11, and data. Okay. Okay. This is just an overview of stuff. That's why, I'm not putting a lot of emphasis on this stuff, just so that you understand. Okay, have a look at this guy. Here we are accepting a name of a file from the user using a scanner object. And then we are giving that full path to the path object to establish the path through the absolute path and then display the path. And that's what it does. You ask it to look for memo.txt and goes and establishes an absolute path and comes back and shows you that stuff. Okay. Do you guys remember this static stuff? I think we learned about it before midterm. Import static. Anybody remembers this? Import static?
I can't say I remember.
Import static allows you to import the static elements. By default, only the non-static entities can be used. So if you have like static constants declared inside a certain class, you can say, I want to import the class access mode. I want to import everything from access mode that is even static. So this is how you can bring in the static stuff into your class and use it as if you can see it through inheritance or other means. So that's what that does. So this particular class access mode has some constants like read, write, and execute to allow you to read, write, or execute files. These constants are declared inside this class called access mode. Okay. Here is an example that we want to be able that on the file path, which is this entire path, to get the file system and check the access on the file path to see if we have read and execute permissions. This read and execute permissions are actually coming from access mode. Okay. Now, what I want you to do is open Eclipse. And once you open Eclipse, you can create a project for this week. And we will create a text file. And then I'll let you know where to put it. Did we do this stuff last week or no? No, or we didn't last time. Somehow I remember doing this stuff. Is this from our class or is it from before? Yeah, this is from June 28th. Yay, yeah, we did this stuff. Hold on a second, I totally forgot that we were actually doing chapter 11. See, we did the path demo and the path demo 2, and we did the read data stuff. You guys don't remember? Do you guys have the same stuff as me? Or no?
Oh, what unit was this?
This was, I did not do it for units. I'm just looking at the dates. When was it last modified? So I'm wondering, did we do this or not?
I have a path demo 2 in my unit 8 file.
Yeah, that will be unit 8, exactly. So and then you probably will also have demo create file 1, 2, 3, 4.
I don't see that.
Okay, what about read data and read data 2?
I have read data in 2.
Okay. Demo create file 1 was a file IO approach, older approach, I think. Yeah, and how you would create a file in the older approach. I don't remember. Okay, so I think we did do some of this stuff. So okay, well, there's no point of redoing it. I'll just review this stuff then, probably. That's better, and then move on to where we should be. So here in this example, what we did, we were tapping into a file called data.txt, which we created down below here. We deleted that afterwards. And then we were checking to see if we have the read and the write permission. That's exactly the same example that I wanted us to do, but since we already did this, there's no point of doing it again. So all it does, it checks to see if we have any kind of permission to that file. Since we don't, so it will just simply go and say no such file or directory. If we do, then it will be able to see, permissions you have. And path demo 2 is basically where we had 2 of these files, data 1 and data 2. And we populated the basic file attributes for both of those files in attr1 and attr2. And then we converted those into the milliseconds for the creation time. And then we checked to see which file was created before the other one. So that was another example that we did. So we compare their times. Then in the read data.java, that's where we started to read the data from a file. And this simple example allows us to load data1.txt into file path 1. And data1.txt simply holds the word John. And what we do is after that, we need to convert that into a buffered reader so that we can read. And you cannot directly put the file into the buffered reader. So that's why we have to first convert it into an input stream reader object and then into the reader object. So I showed you guys how you will do it in 2 steps. In 2 steps, you will do it like this. You will first create an object of input stream reader. So you will take an input, which is, hold on a second. Okay. So this is where you will take your data1.txt, which is the data, John, and you will give that path over to your input stream reader. Since input stream reader cannot automatically talk to buffered reader, therefore the input stream reader needs to come into play from input stream. So you'll take your input stream object, convert it into an input stream reader object, and then you will give that reader object over to the buffered reader, and you would not have to do any of this stuff. But that was a waste of memory because input stream reader was only used in 1 line, and we did not need it after that. Therefore, to overcome all of that, what we did was we bypassed line 14. We created an input stream reader object on the fly, and we gave it the input object, and then the result of that was given to buffered reader to read. And then we read only one line because the file only had one line, and then we displayed the data. So that was the read data. Then the read data 2 is where we looked into the data 2 file, which had multiple lines of data. And after we did the same stuff as before, instead of reading only the first line and displaying it right away, we ran a loop to check to see if the reader is not equals to null, then display the data, which is held inside S, and go and read the next line. So when we run this one, it will display the data. As you can see here in my output, it will display 234, comma Harris, comma 19.65. All of this stuff that was in the file. So I think this is how far we came. And all of this was about coming as far as we were about to start the sequential access. Well, I mean, like, this is all sequential access, by the way. But this is how far we came last time. Read data. Did we do any write data? No, right? Read data 2, or read file 1. Names.txt. Oh, yeah, we also did this one. Names.txt. We had like bunch of names in a file. And what we did with that is we loaded those into a file object. And after, did we do this one? Do you have this one as well? Or you don't?
I don't see a read file.
Okay. I don't know how I have some of these files on, but I don't have all of them. Okay. Okay, so maybe this could be a good point to start. So you guys can right-click on your project and go to New File. And this will be called names.txt. Names.txt. And then you can put these names in the text file and save it. These are just first and the last names. Okay, everybody got the names done? Okay. Then we move over to readfile1.java. So that'll be the file that you will create, readfile1.java. So on line number 8, I'm creating a file object. And I'm loading this names.txt file in the file object. Once I do that in the try-catch block, I'm giving the file object to my scanner because scanner can read any stream. So far, we have been asking scanner to read our input stream from the keyboard, but now I'm changing the stream to a file instead of the keyboard. So it's now reading the stream from the file, which is my file. So it now has access to everything in the file. On line number 12, I'm creating a couple columns, the first name column and the last name column. And I know that when I'm reading the data from the file, I read the whole line, which comprises of the first name and the last name. So what I'm doing is, as long as there is data to read, that's what the while loop does, grab the data from the while loop object, from the file object, and split it based on the space. So what that does, it automatically generates an email, also an array on the fly, an array of size 2, where the first element holds the first name, the second element holds the last name, and then I'm displaying those two elements. And once the loop is done, I am closing my object, closing the try and the catch. This is basically what the output would look like for this program. It will just display first name in first name column and last name in the last name column. Yeah, let me know when you guys are done coding and testing this one. Angelica, okay, it's not done yet. Okay. Okay, got it. Okay. Now I think we also, there's another file called add data. Add data is the file that we did. Do you guys have add data or no, you don't?
I have add data.
Okay. So add data is a simple file that we did, which takes a John string, converts that into bytes because you cannot add string directly. So after we convert it into a byte array called data on line number 12, we start an output stream, and then we give it the reference of the file path. And we want to create the file. If the file doesn't already exist, create the file. And then after we create the output stream object, we then write the data to the output stream object and we flush it and close it. So that's what basically that example was. Okay, now let's move back to your book and let's go to page number 461, which talks about random access files. So far, the files that we have dealt with are sequential access because it needs to be accessed in a sequence to run through it. In the random access, each record is of the same length. So you can simply jump through the records because you know all records are of the same size. So to help you understand this process, there are some methods to keep in mind. One is called an open method, which opens or creates a file, returning a file channel to access the file. Then the position method, which returns the file's position because you want to know where the file is currently pointing at. And then you can set the file's position by calling the position and providing it with a value. So your cursor will move to that position in the file. Then you have a read method to read a sequence of bytes, and size returns the size of the file channel's file, and write writes a sequence of bytes. So after that, let's have a look at this example here where things are slightly different. And this is figure 1128. This is a random access test. We have a file called numbers.txt. Just so that you know, this is how the numbers.txt looks like. It has 0 through 9 and another 0 through 9 and then another 0 through 9 and another 0 through 9 and a 0. So that's how it has, okay? Oh, sorry, in fact, 0 through 0. Yeah, like that, you know. So it has 10, 20, 30, 41. It has 41 characters. So we are opening the numbers.txt file and we want to write the text XYZ. As I told you, the text cannot be written as a string. It has to be converted to bytes. So that's what we're doing. We're converting into a byte array. After that, we take the byte array and put it in a byte buffer object called out. In the try block, we are opening the file, which is the file object of path type, for reading and writing purpose. Again, you got to remember, this is a static. These are static constants coming from standard open option class. So we are opening the file for reading and writing purpose. We are, first of all, putting the cursor at position 0, which is at the beginning of the file. And then we're asking, okay, as long as there are bytes remaining to be read, keep looping and keep spitting out everything onto the screen. Out.rewind. Now it rewinds all the way to the beginning of the file. It has some built-in very cool methods. fc.position22. Now you're making the byte or the pointer jump to byte number 22, and now you start reading again from byte 22 onwards. Then you rewind again. Now you jump to position number 12, and then you keep looping. Now there are two things that we did between the two rewinds. We rewind it to position 22. We rewind it to 0 position, and we jump to position 22. And then on the position 22, we started writing. Okay, what were we writing? We're writing out, and out basically holds XYZ. So we wrote XYZ on positions 22, 23, and 24. Then we jumped to position, then we rewinded back to position 0, and then we jumped to position 12, and then we rewrote XYZ on positions 12, 13, and 14. As a result, look at this. This is how the file was before the run, and this is how the file is. So we made how many write operations? We made 3 write operations. From position 0, we wrote XYZ. That's the very first XYZ. Then from position 12, we wrote XYZ, and then from position 22, we wrote XYZ. So those are the 3 different places we wrote XYZ. So that's what the random access does. It allows you to jump X number of bytes. So what I would like you guys to do, first of all, I want you to create this file numbers.txt, and I want you to put this data in the file, which is 0 through 9, 0 through 9, 0 through 9, and 0. And then save the file. Then write this code that you see in figure 1128 and run it. And this is where you can see the desired output in figure 1129. I'll stop sharing so that you guys can work on this example. And then let me know when you're done with this example.
I'm sorry, what page was it again?
Hold on a second. It was page number 461. 461. Okay, so now let's go to the next topic in the random access files. And the next topic in the random access files is writing records to random access file. We already learned about how you can write to a random access file, but random access file object can be used with the help of a position method to jump so many bytes. As all records are of the same size, you can literally say, because you're starting, the first record is 0, that's why we do n minus 1. If you want to go at the beginning of the 10th record, we want to do 10 minus 1, 9. That means we want to go to the end of the 9th record. 9 times 50 will take us to the end of the 9th record at the beginning of the 10th record, from where we can start writing. So that's why we do the n minus 1 times the size of our record. Here you can see an example in figure 1130. In this example, we are creating a file called randomemployees.txt. The randomemployees.txt, we are creating a set pattern. There is a 0, 0, 0, comma, and there are, let's say, how many spaces? There's 7 spaces here, comma, 0, 0.00. Now, when you are writing this, don't worry about this whole path. You can just write randomemployees.txt. So what you're doing is you are creating a template of 3 zeros, comma, 7 spaces, comma, 0, 0.00, followed by a line dot separator, which is equivalent to /n. But instead of putting /n, which doesn't work in all operating system, when you do system.getProperty line.separator, then that works in all operating system because it goes to the underlying system and grabs whatever is the line separator in that system and puts that towards the end of your sentence. And then you convert your string into bytes and you give that to a byte buffer, and you want to create a 1000 records. In the try block, you create your output stream object, you create your buffered writer, you give your output stream object to your buffered writer, you run a loop. In that loop, using the writer object, you write to the file the string s starting from 0 byte all the way till the length of the string, and you keep doing it till you are done writing 1000 records. As a result, you will have something like this for 1000 lines. And then the next example shows you how you can tap into this and add data. For example, this is one data item, 002 Newman, comma 22.25. So what you are doing is you're writing this record into that file, and the length of the record and length of each line in the file must be the same. That's why we have to make sure that it is 002. It shouldn't be just 2. And Newman is the name of 7 characters long. We cannot have a name more than 7 characters long. So here, I mean, like, because of the template we created, and then we are taking the length of that string and we are converting the string to bytes, which is buffer. And then we are creating a file channel object, which is allowing us to read and write the file. Okay, now we're saying we want this data to be written on the 3rd record at the beginning of the 3rd. So that's why we're doing 2 times the record size. So we're jumping those many bytes. And then we are writing it on the 3rd, at the beginning of the 3rd line. Whatever it is, we are writing to that file. And then we are closing. As a result, it will write this right on the 3rd record. And as you can see with this example, every slot in the record gets filled with a value. There are some limitations to random access because random access forces you that all lines must be same size, and that's the only way that it can skip through. So anyway, I want you, now this will probably be a little bit of a longer example for you to work on. I want you to first do figure 1130. Figure 1130. 30, and that's page number 464. And its output can be seen in figure 1131. And then you will do figure 1132, and that will be also on the same page. And its output can be seen in figure 1133, where you're able to successfully add a record to a random access file. And let me know when you guys are done. Let me clear your previous feedbacks. Okay, so okay, Angelica is still working on. Okay, it's fine. Okay. Next, I want to assign you guys the breakout room activity, 20 minutes, that you will be doing the end of the chapter questions. I'll put you, all of you, in the same breakout room for 20 minutes. Okay? Downloads. Okay, guys, welcome back. Completed the task.
Yes. At the skin of
Okay.
our teeth, yes. Teeth, yes.
Let's see how we did it. Okay. Question number 1.
B,
Question 2.
B,
B. Question number 3.
C,
C. Question number 4.
C,
Awesome. Number 5.
D,
D as in David. 6.
D,
7.
A,
8.
C,
Very good. 9.
C,
10.
D,
11.
B,
12.
A,
13.
A,
14.
B,
15.
C,
16.
B,
17.
A,
18.
D,
19.
C,
And 20.
C.
Oh, awesome, guys. Good job. See, we work together. You got it. Okay. So, next, what we would like to do here is, 1 second here. Let me close the attendance book. I don't think so. Michael will be joining now. Didn't hear from him, but apparently doubt it. I'm assigning you guys another activity, but this time a programming activity. So we will be going to page number, okay, I'll tell you which page number. 484. Yeah, it's 483. Question number 7, parts A and B. I want you to first read the problem. Question number 7, parts A and B. Everybody read the problem? Any questions about this problem?
Does the part where it says record, does that just mean like a text file?
Yeah. So basically you're asking user to enter the student data, and the data will consist of an ID number, first name, last name, and grade point average. Those will be your inputs. And depending on whether the student's grade point average is at least 2.0, output each record either to a file of students in good standing or those on academic probation. So you will have two text files here. You'll have a file called students good standing and the another one for students academic probation. Depending on the student's GPA, you will decide to send the students either to file number 1 or file number 2. So that's the only thing that's different from what you have done in in-class examples. So you will be making that distinction for the students. And that will be based on their input. Any questions about the part B as to what you have to do for part B? So in part number B, you will display each records. You'll display each record in the two files created in student standing, application and exercise 7A. Display a heading to introduce the list produced from each file. For each record, display the ID number, first name, last name, GPA, and amounts by which the grade point average exceeds or falls short of the 2.0. So the student standing number 2 is just a simple display. So you'll have a display for probationary standing and a display for good standing. So you're pretty much displaying data from both files with a proper heading that this is the probationary standing students and these are the good standing students. Any questions? No questions from anybody? Okay. So let me put you guys in a breakout room for a longer time. This time for 60 minutes. And then 60 minutes, you guys can take a break. You guys can do the coding, however you guys want to do it. But we will meet back in an hour. Okay?
Okay.
Okay, sure, that's fine. Okay, so declared a couple of path objects. Cutoff value for accepting input from user is ZZZ. Cutoff value for the decision making for which file to send the student data is 2.0. Declared my output stream for good file. Convert the stream to buffered writer. Line 27, create the output stream for the other file, the prop file, and then created the buffered writer for that. Accepted the student ID from the user. And if the student ID does not equal ZZZ, because that's my cutoff value, if that's not the case, the loop will continue. We'll accept the student's first name, the last name, and the GPA. Okay. Next, what we will do is we will put it all together in one big sentence. So string ID delimiter. What is delimiter? I have a variable delimiter, an object delimiter that holds the comma, so that all of these values will be comma separated. So I have the string ID, comma, first name, comma, last name, comma, GPA, and a new line character after that. If the GPA is cut off, then need to put that into the prop writer class. If GPA is less than the cutoff, which is 2.0. If that's not the case, the student needs to go in the good writer. I accept the next student ID, go back and check to see if that's not equal to ZZZ, and then like that, follow through the process. So the loop will terminate when I say ZZZ, and both buffers will be closed and both files will have the data. So what did you guys do different in this process?
So when reading the question, I didn't end up making it a loop. I thought it wanted you to like run the program different times to add stuff to the file instead of doing a loop.
Oh, no. It'll be one process in which the students are getting beat out in one direction or the other.
So that's probably why it is replacing the first line.
Yes, because if you're running it differently, then of course, every writer will rewrite the previous one.
Hello?
Yes.
Oh, okay, sorry. I don't know. I thought my Wi-Fi died.
Oh. So that's what basically this file will do. As we open the file for file writer, for writing purpose. So how about you guys go back and see how you can fix your code around?
Well, I could probably just move all of my inputs into a loop.
Right,
That
exactly.
should fix.
Right. Yep, it should be a quick fix. Absolutely. Okay, so now I want to share with you the next piece, which is the part 2. The students standing 2. So what I did in this one, I created 2 methods. One is my main method, which is the main method of my program. The other one is a display method. So the purpose of the display method is that every time I read a record from either of the 2 files, I will send it over to the display method. It will receive it as a string. Once it receives it as a string, I know that all the values are comma delimited. So I will put them in an array, comma delimited array, as we already saw in one of the other examples that I shared with you earlier today. So we will split the array on a comma. That's a built-in function of the string class that allows you to split the string into an array. So based on the comma, the array will hold the 4 values. And then I am putting those values from an array to the respective data type. So array 0 will go in string ID, which is a variable I declared. Array 1 will go into first name. Array 2 will go in this last name. And array 3 will go into a GPA after getting converted to a type double. And then we're displaying these values back to the user. So what we're doing is we're taking a difference between GPA and cutoff, which is over under. So we're displaying the ID number, first name, last name, GPA, and over under from the cutoff. Because that's what it asks you, and the amount by which the grade point average exceeds or falls short of the 2.1. So that's what basically the over under does. Inside the main method, I'm opening the 2 files. Once I open the 2 files, I'm putting them into my buffered input stream, and from there I'm putting them into my input stream. Sorry, I'm putting them in the input stream, and from there I'm putting them in my buffered reader. And from there, I'm reading each one of the files one by one. So I'm first reading the prob reader, and every time I read a record, I send it to display the string that I've read, and I read the next record. And like that, I'm going in a loop. And then I start the same process with the title good standing. And now I read the other file and go in a loop till I'm done with all the data sets. So that's what basically I'm doing with the student standing 2. I don't know what approach you guys took or are planning on taking, but I thought I would share with you the solution. So what are you guys working on right now?
I'm working on cleaning mine up and adding a loop.
Okay, in the first one or the second one?
In the first one.
Okay, Bart and Sam.
Doing the same.
Okay, okay. For your reference, I have posted the two files in the chat where you can download them from so that you will have them on your local computer with you. So around 8:30-ish, we'll start with chapter number 12. We'll give you, 8 some minutes extra to work on your files. Okay, guys. We will now move on to chapter number 12. So chapter number 12 is about recursion. Recursion is pretty much like a loop. The only difference is that in recursion, you repeat the same process over and over again till it reaches a certain point, and that's when you start going the backwards direction. Recursion is done with the help of functions. Unlike loops, which are only one directional, recursions are two directional because first you call the function over and over again till you reach the end point, and then you start calling the functions back because they are in a stack form. You go first call, second call, third call, fourth call, and then you go third call, second call, first call, and then you exit out. So recursion is another way to solve the problems. There are some problems that requires recursion to solve because loops don't really do justice to solving those problems. So programs that use recursion have recursive methods. The methods call itself, which is a new idea for some of you. I don't know if you have recursion in a few other classes or not. But here is an example. Main makes a call to message method. Message method within its body is calling back itself. Now, this is not a good idea because this is where a message is calling itself without an endpoint. The message should only call back itself with some endpoint. Here, it will generate an infinite loop, and that's why it's a bad idea to do. Let's have a look at this approach. Main is calling the message method and passing a parameter 4. Now, message method has a condition. If the value of reps is greater than 0, then display the reps and then call the method again with a value less than the previous value. So in first call, it will be 4, second call 3, then 2, then 1. Then when it becomes 0, the if condition will fail, so the method will stop calling itself, and now things will start winding back. As a result, the first time you make a call to method with a value of 3, the message 4 will print, and it will wait for 3. And then in the next call, 3 will print, I'm going to wait for 2. Then 1 will print, I'm going to wait for 0. And then 0 is when start wrapping back up. That's why the output is 4, 3, 2, 1. So that's how the recursive calls work. Any questions, guys, so far about recursion? As to how it works?
So it's a loop that I'm sorry, could you just uh, repeat that?
It acts like a loop, but it's not really a loop. It is a method that calls back itself, and it keeps calling itself until a certain condition is met. When that condition is met, the method stops calling itself and starts going back, because whenever the method calls itself, the caller stays in memory while the called runs. Then called makes another call back to itself, so it becomes a caller, stays in the memory, and the next call takes place. So when the last call takes place, after that, it starts winding back to the very first call it made to itself.
Okay. Okay.
So that's how it first folds. And then it unfolds and then folds back. One of the biggest advantage of that approach is that since it goes in two directions, when you are folding back and you decide to unfold it again, you can do that because you're still in the process. So the mathematical problems where you would want to make certain decisions, in one way or the other while you're looping in one direction or the other, you could do that with recursion. So usually mathematical problems are solved with this approach. Now, have a look at this example here. We have a class called sum of numbers. Main method makes a call to sum numbers and passes the value 5. If 5 is not equals to 0, which is not, then what it does, it returns a value, right? But look at the return value. What is the return value? 5 plus, and it makes a call to itself with the value 4. So the return will be hanging in the air because the return is not complete yet. So that 4 calls now comes back, and since it's also not equals to 0, it now makes a call 4 plus, and it makes a call back to itself with a value of 3. And then 3 makes a call to itself with a value of 2. 2 makes a call back to itself with a value of 1. And then 1 makes a call to itself with a value of 0. When that happens, then it returns 0, because if condition fails, it returns 0. And now, since it starts returning values now, so the 0 returns a value to the previous call. So the previous call gets a 0. So now 1 plus 0 gets to return a value to the previous call, which was 2. 2 plus 1, which returns a value of 3 to the previous call, where 3 was waiting. 3 plus 3, 6, which returns a call to the previous call, which was 4. 4 plus 6, 10, which returns a call back to itself, which was 5 plus 10, 15. You follow that? I want you to read these bullet points right below figure 12.6 on page 490. And let me know when you're done reading. And whenever you're done reading the bullet points, look at figure 12.8, where author is providing you with another solution. And in this solution, in figure 12.8, instead of having to wait till everything just folds back, the author provides you intermediate values. For example, when you make a call with a value 5, it shows 5 and waits. And the next call will display 4 and waits. The next call will display 3 and wait. Next call will display 2 and wait. Last call will display 1 and wait. And now it starts unfolding back. So that's when it shows 15. So that's another indicator of how the progression happens. 5, 4, 3, 2, 1, and then it falls back. So the folding process, when it starts, that is called your base case. That's where the folding process starts. So this is basically recursively adding all the numbers from the highest number to 1. That's what this method does. Do you guys know what are factorials?
Yes.
Okay, it's basically the same thing as this one, except for instead of addition, we do multiplication. So the factorial of 5 will be 5 times, 4 times, 3 times, 2 times, 1. So if you now go to the next page, which gives you a factorial solution, that's exactly what it does. So when it makes a call, for example, the author takes a number from the user, let's say the number is 5. He makes a call to factorial with the value 5. And what factorial does is this: if the value is equals to 0, that's the base case. You start returning. If not, then it is, let's say, 5 times, and then it makes a call back to itself with a value of 4. And then that makes a call back to itself with a value of 3, and then that makes a call back to itself with a value of 2, and then that makes a value call back to itself with a value of 1. And then when it hits 0, that's when it starts returning 1 to the previous value. So 1 times 1 is 1, which returns that to the previous call, which is 2 times 1. That returns to the previous call, which is 3 times 2. Then that returns to the previous call, which is 4 times 6. That returns to the previous call, which is 5 times 24, and that's 120. So every return returns a value to the previous number that is waiting. So that's basically how the factorials are. So the
Okay.
previous example was about addition, and this example is about multiplication.
Okay. So essentially, it's like the deeper you go into the method, you're setting up the numbers, and then when you get back, you're doing the math.
Exactly. So how about you guys code this one, figure 1210? Figure 1210. Let's see. That's page number 492. After that, we will now see how recursion works with strings. So that's page 496, where the author is sharing with us a program which talks about how recursion helps separate a phrase into words. So the author is asking the user to enter a phrase, a sentence. When you are done entering a sentence, the author sends the sentence over to a recursive function called break into words. So what that does, it starts looking at the whole sentence. Okay, so let's say a sentence is, this is my house. So when you say in the sentence, I want to look for a space, it only looks for the first space, which is after the word this, right? What we want to do is we want the index of that location where the first space occurs. As long as there are spaces occurring in the sentence, that means there are words in the sentence, words. That means there are more than one words. If there's only one word left, that's when the index of will return a -1, and that's the base case. So if space is equals to -1, that means only one word is left. Okay, if that's not the case, look at the recursive call. This is a very, very interesting way of looking at it. What is the author doing? He's making two calls back to the method itself. The first call reads the word from the first placeholder till the space. And the second one passes everything after the space. So in this is my house, one call will pass this, and the second call will pass is my house, right? Now this, when makes a call back, this is the only word, so it spits out this. Is my house is called, but that's 3 words. So it picks is out and sends my house back, and then is a spit out. Then my house sends house out and spits out my. And finally, since house is the only word left, it spits out house. So this is my house, or somewhere over the rainbow, it will first spit out somewhere, then over, then the, then rainbow. So it just goes like that. So it just creates 2 branches, one branch to display the only remaining word, and the other branch to dissect and only extract one word for the next call. Okay, go ahead and read the description under this figure 1214, and then solve this problem, figure 1214, on page 496, and then test with the output shown in figure 1215. So page 496, figure 1214. Okay, guys, next I will be asking you to go to the end of chapter number 12 and do the review questions. I'll put you both in a breakout room for 20 minutes. And then when you come back, we will then discuss chapter 12 review questions. Collections are Java classes to replace arrays because arrays are limited and collections are not. And generics allow you to create one class and use it a million times kind of approach. So both of these concepts we will cover in chapter 13, and then if we have time, we will transition to Java FX. Just so that you guys know, again, as a reminder, that we just have 2 more classes before the finals. So July 26th and August 2nd. And then the final exam will be available to you from 2nd through 9th. Yep. Pretty close.
Yeah, a bit closer than I thought.
Yeah. Okay, guys. Have a good night. Take care.
You too. Hope you feel better.
So have a good evening.
Thank you. Bye. You feel better too. Thanks. Bye-bye.